Good day to Dr. Bushro and also Dr. Su. We are from Group 2.1, speaking about electronic vehicles under science and technology. My name is Navinraaj Nosivanatha, matrix number 2306567
My name is Muhammad Irfan Zarif bin Yusri. My matrix number is 22001672.
My name is Kuhanesh Devandran. My matrix number is 22115321.
My name is Aiman Zakwan bin Halim. My matrix number is 22001578.
And my name is Muhammad Harith bin Muhammad Salihin and matrix number 22000946.
Talking about the introduction, electric vehicles are very much seen in our country today. For example, Tesla, BYD, and so much more. We understand that it is a very sustainable transportation because it reduces our dependence towards fossil fuels and also cuts the greenhouse emissions because it brings a lot of negative effects. We used a model which is a remote control car to help us understand how the DC motors drive vehicles. It mimics the actual electric vehicle. We powertrain the setup of the real EVs. Okay, we use certain number of components, capacitor, inductor, resistor, and so many more. So we know that the DC motors offers high torque and also efficiency. So using that, we were able to mimic the EV and also produce quite some number of results using that. We were able to scale the model of the actual EV, which involves a more powerful DC using this tiny DC motor. The case study provides a very simplified yet effective way to understand how DC motors role in driving a better transportation forward. I will move the topic forward to Kuhanesh.
Okay, as for procedures, the first is for to connect the power supply, and the second is for the breadboard configuration. As we place the L29 3D IC on the breadboard, we connect the four DC motors, and as well we add the resistors and capacitors. For the next one, which is the microcontroller connection, whereby we connect the microcontroller and as well as we program. Okay, later onwards we program the microcontroller to send the control signal. And later onwards, as for the testing and calibration, we check all the connections and we run the test, okay, run the program to verify the motor control. And for the data collection, we record the RPM values for the motor under the different control signals. Okay. As for the flow chart representation, first we define the requirements, design, circuit, and simulation, which is done by Navinraaj, obtain components, assemble prototype, testing and validation, and optimization.
Okay, for DC series motor, there are two functions, and the first one converts electrical energy to mechanical energy, and the second one is to connect the armature and field windings in series with a common DC power source. Okay, next. Next, we will go to the list of the components. The first one is battery, second is DC motor, and then third H-bridge motor driver, slide switch, resistor, capacitor, and inductor.
I'll be talking about the function of battery. Battery is an electrochemical device. It is a component that we use in our everyday life without us realizing it is there in literally everything we use. Okay, so it stores chemical energy inside and it converts the chemical energy to electrical energy. It is the most convenient way to store and also transport electric energy anywhere, anytime. It's also a backup power source during power outages at our home also. Okay, the next.
Okay, so the next component that we use in our product or item is DC motor. So DC motor is a electromechanical device that can convert electrical energy into mechanical energy. So the reason why we use DC motor because we use battery as our power supply. So direct current is a suitable type of motor that we should use. And DC motor is easily to control by adjusting the voltage applied, and also it can provide high starting torque.
So the next component is H-bridge motor driver. So the function of H-bridge motor driver is to allows bi-directional control of a DC motor and precise control over the motor's direction, which means we can control the direction of motor to clockwise and anti-clockwise. The next thing is to control the motor speed, and H-bridge motor driver also control the deceleration of the motor, and it minimize the energy loss.
As for the slide switch, it's a type of electrical switch that controls the flow of electricity in a circuit. Okay, it's a feature of a small lever or a slider that moves between in different position, typically off and on. So it basically slide switch is easy to use and understand, making them suitable for a wide range of application. And as well, they are known for their reliability and their longer lifespan. Next.
All right, the next one is register. There are five functions for this component, and the first one is to limit current flow, meaning that controls the flow of electric current in the circuit. And the second one is divide voltage. We actually can divide the voltage between two paths of circuit. And the third one is to protect components, which means that we can prevent damage to the sensitive components by reducing the current. And the fourth one is to set operating conditions to help ensure the components work within their intended range. And the last one is works as energy dissipation, meaning that converts excess electrical energy into heat. Next one.
Okay, I'll be talking about the capacitor. Capacitor's most important role is to store energy. It temporarily holds the electrical energy in the electric field. In our daily appliances, we can also see capacitor is actually there. Um, it also provides a smooth voltage flow by reducing the fluctuations in the power supply. By filtering it, actually, it blocks the DC and allows AC signals to pass while blocking the DC. And also a timing control, meaning it can work with the resistor to control the timing in the circuit, because its timing is very important in our remote control car, which will mimic the EV. Finally, it also signals the coupling and decoupling, meaning it can transfer or isolate the signals between the circuit stages. Next.
Okay, so for the last component is inductor. So the function of inductor is firstly is to store energy. So it temporarily holds energy in a magnetic field. Next is inductor resists current change. It opposes sudden change in current flow. And inductor work as a filter signal. Inductor blocks high frequency signal whilst allowing a low frequency to pass through it. The next is inductor create oscillation. It work with capacitor to generate oscillating signal in circuit. And last function for inductors is it work as a voltage boost. Inductor help to increase the voltage in some power supply design such as transformers.
These are our findings from the software that we use, which is Tinkercad. So this is the maximum voltage and also the reading of voltage and current that we obtain by using the Tinkercad simulation for our product is 30 volt and also 1.31 ampere for current. And the result that we obtain from the simulation at Tinkercad is the motor control. So the model of motor driver that we use is L293D. So that model of a motor driver we use to control the 4 DC motors. The motors are connected to the output pins, and the motor driver is powered by the battery pack and the power supply. So for the power supply, we set we set to 30 volt and also 1.31 ampere. So these values are sufficient for both voltage and current to drive the motors and the circuit. So it is the good value for to run the simulation.
Okay. As for the motor, we have obtained different RPM values, which indicating that they are running at a different speed. Okay, the negative RPM value, one of the motor suggests that it's running in the reverse direction. And for the last, which is the circuit connections, the breadboard has multiply connections with resistors and capacitors, which are likely used for filtering and stabilizing the circuit. The wires are connected, okay, to appropriate pins of the L293D IC to control the motors. Next.
Regarding the limitations of the findings, we all know that simulations and real world differs. So meaning the simulation may not accurately represent the real world conditions. There is also friction, motor load, and other factors that might affect the real world condition. Simulation may feel smooth, but in real world there might be defects. Regarding the RPM accuracy, uh, the RPM values might fluctuate because it's not entirely accurate. It lacks the real-time sensor feedback. So discrepancies might occur when we look at the RPM. Next. Okay, schematic diagrams. As you can see, there is four motors there. One bridge switch and capacitors, power supply, and all the important components are used in the schematics, and it is well shown in our sheet here, which is also made using Tinkercad. Next sheet, I will show the simulation that is done by us. As you can see, once the simulation is started, um, you can clearly see I've shown where is forward, where is backward, and the location of the motors. As you can see, this is a four-wheel drive which has been modified. When I put the most perfect 30 volts and also 1.31 ampere as what has told by Irfan, we can see that all the four motors are running. At the same time, we can also, using the switch, we can affect the movement clockwise or anti-clockwise of the motor. This actually helps to run the motor smoothly. You can clearly see the video is running well and the simulation works. This is the schematic. Thank you so much for giving us this opportunity to help us learn more towards the DC motor and also learn something more using the Tinkercad as well, Doctor. So, guys, please open your mic and say thank you, guys. Thank you,
Thank you.
Doctor. Yeah,
Thank
thank
you,
you, Doctor Shu
Doctor.
and Doctor.
Thank you, Doctor.
Thank you. Come on, guys. Yeah.